All right, welcome back, everybody. We've got some more Excel tips and tricks for you. This one pertains to your lab 2. So let's get started. Hopefully this will be a little bit shorter than the first one. So what we're going to talk about today, we've got formulas for our lab. Got using $ in Excel. So these formulas in the lab is just a review. Using $ in Excel is explaining a little function that we see in Excel. And then the last two, table of sample sizes per year and allele frequencies over time, these are the actual pieces of information that you will need to complete your graphs or tables for the lab. All right, so just a quick review here how formulas work. We've got our average, sum, count. We've got our average if, sum if, count if, and average ifs, sum ifs, and count ifs. So all of these perform mathematical functions on selected cells. And in this case, it's going to be the average, the sum, or counting instances. And then as we get a little bit more complicated, we can average things if they meet a single criteria or a multiple criteria. We can add them together. If they meet these criteria, we can count them. These are the things that you need to know. And this should be familiar because we saw this last time, and we also used a couple of these. I believe we used count if and average. Excuse me, average if. So today we're going to do something a little bit different. And I'm also going to explain something that you've seen a little bit, but might not have really known exactly what you're looking at. So why do we see $ in Excel? What does that mean? It doesn't perform a mathematical function. We're not talking about money. So what is it? So in Excel, when you drag formulas to other cells to fill them in, to auto-populate, dragging these formulas to other cells will change their references. So what do I mean by that? We've got some examples here on the right-hand side. So when we're talking about references, we're talking about these cells that are inside that parentheses. So what we're actually performing our operations on. So in this case, we're talking about, let's say, the average function. So we want to average the cells A1 to A10. We've got that written in there. And say we want to fill in a table where we've got all these different averages. If we were to just drag this formula over, you'll see that Excel automatically changes this to a different reference, a different cell. In this case, it's changing it to 1 to the right because now our formula is in a cell that's 1 to the right of the original. But if we were to drag it down, you'll see that something else has changed. Instead of A1 to A10, now we're averaging A2 to A11. So it's averaging everything one cell down from what we originally intended. And that's when you don't put any $ in. But if we want to make sure that everything stays the same, in a formula, if we add a $ to a cell reference, this $ makes that reference absolute. It means it doesn't change no matter where you drag it around unless you go in and manually change it. In Excel, there's 4 ways to write a reference to a single cell, and Excel will see these as all the same. You can write it as A1, no $, $, A1, $A, $1, and A, $1. Excel will see all of these as just A1 and look for whatever. But when we move them around, that's when things start to change. So the original, this is how things change when you move the formulas around. But we start adding $ in, and what happens? If you've got the $ before the A, and just the A, this means that we're always going to be looking at column A, but the number might change. So going over to the right, it'll change, or it won't change anything really because we've frozen this A. But if we move it down, we see that the 2 has changed. A is still the same because it's got the $sign in there. But A1 is changed to A2, A10 changed to A11. Same thing over here. Because we've moved down, that number has increased. And then if we want to freeze everything, we've got our $sign in front of both the A and in front of the 1, then A in front of the 10. This freezes everything. No matter whether you copy and paste it or drag it anywhere, this will always stay the same. Excel's not going to make any adjustments. And then finally, if we've got the $sign just in front of the number, not in front of the A, we are freezing these numbers, but not the columns, or the numbers represent the rows. So if we were to start with this one and we drag it down, we see that everything stays the same. But if we start with this one and we drag it to the right, we see that the A has now changed to a B. And this is just, it's an annoying thing that Excel does if you're not prepared for it. And if you're finding that your formulas are broken for some reason, or they're referencing random columns or random cells, this might be the way for you to fix that. All right. So let's get into the actual tables that you're going to make, the tables and the charts and the graphs that you're going to make today. And this information is also in your lab manual, but I'm just going to go over it really quick here, and then we will do it step by step in Excel for you to see. All right, so the first one, we're making a table of sample sizes per year. This is a little different than the first thing we did, where we just counted how many instances or how many assays were performed per year. This year, or this time, we care about how many total mosquitoes are sampled per year. So for this one, we're going to copy the end year column to the side, utilize remove duplicates, get all unique rows, sort that. So we've got our years in order. And we're looking to title our next column mosquito count, so total number of mosquitoes. And here we're using a different formula that we haven't used before, but functions very much the same as what we've used previously. We're going to be using the sum if formula to count how many mosquitoes were counted per year. And then optionally, you can generate a bar graph to see what that looks like. But what you need to turn in is just the table that you end up generating. And then the next one, allele frequencies over time. So for this one, what we're going to do is starting out very similar. We're still looking at, since it's over time, we need to extract our years. So copying the end year column to column O, remove duplicates, get all the unique years present, and sort your new end year list from smallest to largest. And then we're going to make a table of allele, and then our first allele of interest and our second allele of interest, which are included in the data set. And then we're going to transpose paste, which we've done this once before as well. Your end year list into cell R1. And then R2, we're using average if again. And here we see the $signs make a reappearance. So now that you've seen what the $signs actually do, maybe this looks a little bit more familiar to you. And then R3, average if, same thing. We are changing the formula a little bit because we have to look in 2 different columns for our allele data. And then we want to fill to the right to complete the chart. Okay, so those are the instructions. So let's dive into Excel so you guys can see this in action. All right, so here we are in Excel, and just make sure you notice that this is a different, it's a different spreadsheet than the one we've used before. I'm going to make this a little bit bigger for you guys. Okay, so we've got Lab 2, 8. We're looking at allele frequency, survivors, and dead. So this is a different data set than what we used in Lab 1. All right, so first thing, we want to copy the end year column by clicking that F, hit Control C, or right-click copy. And then let's go over to column O, hit paste. Great. And let's see, we want to go to data, remove duplicates. My data has headers and year. All right. So we've got our unique years here, which is a little different than what we saw in the first one because this data set goes back a little further. Great. So we've got those remove duplicates. Let's go to sort in the data tab. Again, select my data has headers, smallest to largest. Okay, great. And we don't want this no response. So we're going to go ahead and delete that. Okay. Next up, in the next column, we're going to title it mosquito count. And if you double click the line in between two columns, it'll automatically adjust the width. And you don't have to do that, but I like the way it looks better. So it does look nice. All right, so now we're going to use our sum if formula. So equals sum if, and what we care about, we're looking for the range of the criteria that we're looking for. So we want to find in our year of each year, if it happened in 2002, we want to sum our number of mosquitoes. And here you go. Hit enter. And for this one, since we're just going all the way down, we don't even need to add in any dollar signs or anything. You'll see this is what I mean by filling down or filling to the right. So if we just fill down one, what you'll see is that automatically this reference, this 03, it used to be 02 up in this guy. But since we dragged it down one, now it automatically goes down to that 03. It increments it by 1 to follow our references. All right. And so if we just double click, there you go. There's our data table. So if you want to make this a bar graph, you can. It's not required. But this is the mosquito count per year. So if you wanted to make it a table, we could highlight this first. We go over to insert. Let's go to recommended charts. Let's see here. Personally, I like this one. Looks nice. And you can see the trends in the data here. We've got our years across the bottom, mosquitoes. And what you want to make sure you do with these is you want to make sure that you have a couple of things. You want to make sure you have axis titles. You want to make sure that you're graphing the right thing. Great. So go over to this little plus over here, and it's chart elements. So easy enough to do here. We can add axis title, and it doesn't automatically generate the titles for you. So you're going to have to click on it, double click, and across the bottom, this is year. And across the y-axis on the left-hand side, this is number of mosquitoes. And there you go. That's your chart. All right, so we're going to get rid of that for now. And I'm actually going to delete some of this data. Delete. Oop. Okay. All right, so the next thing we're going to look at allele frequencies over time. And what I just did to the data is going to make my chart end up looking a lot different than what yours might look like. So you can follow all of these steps that are listed in your lab manual, but I'm going to need you to actually do them and submit the screenshot of your chart versus what I'm about to make, because it will look different. All right, so we start out the same way. We've already got our end year column, so we don't have to do this twice. We've got it. So let's move over. I'm just going to get rid of this so that we can have a free column in between here. In Q1, we're going to type allele. So that's going to be our row title. In Q2, we're going to type L101 for L. And in Q3, we're going to type L101 for F. Great. Easy peasy. So now we're going to highlight from 2002 to 2013. And we're going to copy, either Control C or right click, copy. Then we'll go to R1, right click inside, and you'll see this transpose paste. You want to click that because this helps us set up our table. Really super easy. Great. So now we've got our years across the top, and we have our alleles across the left-hand side down. All right, so in R2, here's where we get into our formulas again. Average if, and we're gonna have to utilize these dollar signs because we want to fix these references in place. So K to K, what is that referencing? That is referencing our column L1014L %. So that's where our allele frequency comes from. And we want to, oh, I'm sorry, one second. We are going to do average ifs. So you want to make sure you definitely have that S in there. All right, so first thing we're referencing still is this average range. This is where our allele frequency comes from. And then we go to our first criteria. We want to only average allele frequencies that happen in specific years. So click on column F or simply type $F, $F with that colon in the middle, comma, and we want R1, which is 2002. That's the year we're looking for. All right, hit enter, and it gives us a number. Great. Okay, now we can't just fill this one down because we actually have to look in a different column for this. We go equals average ifs with the S, and we want to do L, so $L colon $L colon. And you'll see we're looking now at the L101 for F allele % frequency. That's where we want our numbers to come from. So comma, and then we want to look again in our end year. We only want to average data that comes from, comma, 2002. And that's going to be all we're going to look for. Hit enter. Great. So now we've got our allele frequencies in the total population of this allele, L101 for L and L101 for F. So approximately 93% of the population has one allele, and approximately 7% of the population has this other allele in 2002. So we want to see how this changes over time. So we highlight both of them, and we drag them all the way over to the end of our chart in 2013. Okay. Now on your chart, you might see some different numbers. these in particular will definitely have numbers. Looks like what I did is I deleted the 2012 and 2013 data when I removed that. But let's take a look at what this line graph looks like. We want to make a line graph out of this guy. So again, highlight it all and go to Insert, Recommended Charts. All right. And you see there's a line chart there, but let's look at all charts. And we go to line. And this is nice. That's what we're looking for. There should be two lines because you have two variables that you are graphing here. And again, we want to make sure that we have our axis titles. So let's do that, axis title. Across the bottom, we've got years. And across the y-axis on the left-hand side, this is allele frequency. Great. And you can keep a chart title. You can get rid of it. It's not 100% necessary. This is allele frequency over time is what I would call it. And then you can see in the legend here, you've got the dark blue line representing the L1014L allele, and the L1014F allele is the orange. So again, yours will look different because I removed data. But this is how you get there. This is how you visualize it. So I hope that's helpful, guys. Let me know if you have any questions, and I'm looking forward to seeing your graphs. Thank you.